So now I am going to show you how to use Enterprise Miner, how to build a model, and specifically how we built our Vaers model. This is going to build upon what Stanley has already showed you guys about how to clean the data and merge it together. We're going to use that data. So when you enter Enterprise Miner, this is what the screen looks like. Not too fancy, but it's easy to use. So you're going to click on New Project. Sometimes SAS is a little slow on the server because this is like cloud-based, so just be patient. Click Next. You're going to name the project. We named ours Vaers. You're going to click Next. Oh, I already did this one, so it says I already have something. Name that. So let's name it something else. So now you just see where it's at and where it's going to be located at here. Click Next, and then you can click Finish. Now I'm not going to create this project because I already have one created. This is a screen you're going to see when you have created a new project or when you open back one up that you have already created in Enterprise Miner. So there's a few things. This is your project name right here. Data source is where you're going to put the data, the SAS data sets that we've created. I will show you how to do that in a bit. Diagrams is where the model actually sits, and I will also show you that. So let's go ahead and bring in our data sets from SAS Studio. The great thing about SAS Studio and Enterprise Miner, especially if it's on the cloud, is that they connect with each other. They actually talk to each other. So when you create a data set in SAS Studio, we can grab it from there without having to find it on our desktop, but we can also do that. So to do that, we have to write just a teeny bit of code. So you have your project here, and then in the Properties tab, you click on the little dots next to Project Start Code. That's going to pull up a little dialog box where you can write some code. Now, I wrote this code here, so this you'll have to write in. Basically, you're telling it to look for this, you're naming a new library, and then you're telling it the location, just like you would any SAS coding. Now, the location here is actually in SAS Studio. So I'm going to show you that real quick. I'm going to switch over here to SAS Studio. And where I got the location of this is you go and you right-click on the folder that you have the SAS datasets that Stanley showed you how to create in SAS Studio. You click Properties, and you just copy right here where it says Location. Control-C to the, you get what I'm saying, Control-V. So you copy it here within quotation marks, semicolon, always semicolon. That's what SAS stands for. Just kidding. And then you're going to do your run statement, and then you press Run Now here. Now I've already run this, so I don't have to run this again. And then just, it'll show you like errors, or it'll tell you something if it doesn't run. And then you press OK. Now this is pretty cool because next what we're going to do is get our data sources for our model. So now we're going to read in our data source here to create the model, the SAS data sets that Stanley kind of showed you how to create. You can also get these from your desktop or like your documents if you have them. But this is where it's going to be really cool to see the bridge between SAS Studio and Enterprise Miner and that little piece of code that we wrote. So you can already see I already have some data set sources in there. But to create a new one, you right-click, Create Data Source. It's going to bring up a wizard for you. Keep it on SAS Table because that's the type of data we're reading in. Now, we're going to click Browse. And then when that pulls up, it's going to show us the folder that we read in from SAS Studio. It does take a few seconds, so be patient, and you will learn patience with EM and being kind of on cloud server. So this is a library that we created with the code. And then after that library name, we shared a location of where the data sets were. And this is the data sets that's found within the location, which the location was our SAS Studio folder. So all of these data sets, these SAS data sets, are now within Enterprise Miner to use. We're going to go ahead and click one of our merged kind of completed data sets here and click OK. Now that that's in there, press Next. This is just some general information about the table. You're going to go ahead and click Advanced. What that does is it kind of guesses what roles and levels your variables are. So, for example, it's kind of guessed that the years are integral, the ER visits is unary, there's binary, nominal, and it's guessing if it should be inputted or rejected, or if it's the ID. A lot of times this is helpful. We don't want to rely on that though, because we're going to probably change some of these later just based on business value and just common sense. So for right now it's okay. We're going to press Next. Now, creating a sample data set, we don't need to do that with a specific case because we do have years of data that we know. If we only have one data set that we only know the answers for like this one data set, we would want to take a chunk out of that to score it and see how accurate our model is, knowing the answer of what we want, knowing our why, just so we can see how much is correct and how much is not. In this case, we have other years to kind of do that with, so we don't need to create a sample data set. So we're going to go ahead and click, keep that on no, click next, my bad. And then this, nothing here, just click next. And finish. So we successfully read in this data set. So this is the diagrams box here. This is where we're going to create our model here. So this one I have already created the Vaers diagram. To create a new one, you right click, create diagram, name it something. Oh my god, analytics queen. Okay. So you're going to see this pop up here. This is a diagram box. This is where you can add all your nodes that are going to connect to make a model. It's awesome. Up here, you can click on all these tabs. These are all nodes that you can use. So a node just looks like, I'm going to bring it down here. This is one node. So it looks like a rectangular little box here. Each one has a different function, and then we're going to see how kind of they connect to each other, what goes in, what goes out. But there's so many that you can play around here with Enterprise Miner. What is awesome about this as well is that each node is basically a bunch of code. So if you had taken Stats 307 and remember writing all that code from scratch, the code that it would take to write one of these nodes is crazy, ridiculous, and it would take you forever. So that is what's really special about Enterprise Miner here. This is where the real fun begins, where you get to really play around with EM and have fun with all its nodes if that's what you're into. So this is our model here. As you can see, it's a lot of different types of nodes bound together here by these arrows, creating our model, our final output here, which is our score. I'm going to go through each of these nodes and kind of mention what they do and how they end up creating this model here. First, this is our data node. This is what everything really needs to kind of stem from, because this is where you're going to create your model. We've already read in our data, so you can either just click and drag it on, and this is your data node for that specific time. Let me delete this here. Or you can come up here, and I think there's a node, yeah, there's an input data node that you can drag down. Excuse me while I delete this. Yes. So we read in the Vaers 2015 data. We found that it just had the best data to work with. As far as your properties, there's really nothing you have to change in this box here for this node. And every node, you'll see there's the different properties here that you can change. There's also things, if you right click, that you'll see. So within the data set, we need to edit our variables. We don't necessarily want to just take what the advanced wizard told us and just roll with it. We want to check and make sure, yeah, that's right. These are the things we want to keep in the model. These are the things we want to take out. We kind of want to have control of that. The first is the ID here. This is just to specify each row as being individual, kind of like a key in a database. So for this specific case, it's our Vaers ID is what's going to separate each row from each other. So if you click here, it'll let you change these to whatever you need it to be. Now, series condition, this is our Y. We changed this to target because this is our target and it's binary. Now we really need to, and I think that the advanced already did this for us, but we rejected the ER visits because it was kind of what was used to create this new variable here, our target. And we created this new variable in SAS Studio. So this needs to be rejected because it's pretty much the same as this. Everything else is inputted. Now notice here we have our symptom text. That's where you basically have a line of the doctor's or nurse's notes. It's just them typing. This is what's going to be really cool about this model, is we're going to incorporate the text. So this is text. That's kind of different from a lot of other models that you might see with just numbers or categories. The reason that hospital days is rejected, well, you can click this box right here. It's going to show you some quick statistics of each of the variables. Now, what we see here is that in data sets, nothing, especially in the real world, you're not going to have all the fields filled in. There's going to be a lot missing. You just have to kind of be aware of that. Now, a good real practice, if you have 97% of the data missing in that field, you probably need, let's just say you definitely need to drop it. So since we had 97% missing, it's rejected. It's not coming in the model. Now, you might look at this and say, well, there's 80% missing there. Now, this is our target variable. As long as we have about like an 80-20 or better split between our target variable, that's okay. If it drops down even more, that's a problem. We need to find a data set that has more kind of yeses to nos. And 80s, I mean, that's not great, but it's acceptable to have basically 80% missing for an ER visit is they didn't visit the ER, and 20% not missing is they did visit the ER. So it's about an 80-20 split for our Y here. We did reject this because, like I said, it's the same as the target variable there. Looking at the other variables, this one's 54% missing. We'll keep it in there for now. And so now that we have all our variables just the way we like them, we're going to press OK. We're going to look at some nodes that deal with exploratory data analysis. So you can graph in EM, you can look at scatter plots, bar graphs, everything. Might not be as pretty as like SAS Studio, but you can do it, and you can see some basic stats about the data, graph it, plot it. These three nodes are in the Explorer tab here. They're up here. Now what you can see is that there's an arrow going from the data set to the node. To do that, you'll see the pencil mark here. You just drag it and drop it to the node. Basically what this is doing is, this is a data source. It's exporting the data that you read into all these nodes that it's attached to. And every time it goes into something, it imports that data, it imports the previous data set, and then it will export like the change that the node has made. In this case, the only node preceding these three is the data set, so it will just send the data set here. We'll talk about the data partition in just a second. So these three here just kind of explore the data. They're not, you'll notice they're not connected to anything else here. To run these nodes, you'll see this green check mark. That means it's been run. You right click, and then click run. This will ask if you want to run it, and you say yes. It will take a few seconds to run, and when it's run, it'll have a green check mark and give you the option to see the results now or later. To see the output or the results of the node, you can click results after it runs directly, or if you just want to see the results later, you right click and you can click results. Now I already have this pulled up. This is a result of the Stat Explorer node right here. It'll just pull up all these little windows. You can maximize them, minimize them. You can X them out if you want to put other things in here. This specific node shows us the importance of the X variables to our Y, our series condition. This is kind of a bar graph. Preliminary just shows us how the relation is arc chi-squared at this point in time. This is only categorical variables in this bar chart, but it just shows that sex is pretty highly correlated to series condition at this point in time. And you can just play around with those. So the data partition is the next thing we'll get into. This is a very important node as it's going to split our data set up into a training and a validation data set. It's very important to do that. We're going to have, in this specific instance, you're going to change these here. We're going to have 70% of our data set be our training data set. This is going to train the model. This is going to kind of create the model. And then the validation data set is going to see how accurate the model is and kind of help us gauge if it's correct or not. The reason we have our test as 0 is the same reason as we didn't create a sample data set. We already have other years that we can test this further on. We really don't need that. So that's why we're only splitting our data sets into 70-30. This partitioning method is super important because we need it stratified. What this does is it creates an even proportion between our serious conditions and not serious conditions within our training and our validation data set. We want the proportion of the Y and not the Y to be the same, about the same in both. It really needs to mirror each other. That's very important. So we're going to keep that stratified on our target variable. And we had indicated our target within this node here, so we really don't need to say anything else and change anything else other than just a 70-30 here. So I've run this. So let's look at the results here. Okay, so this only pulls up one kind of dialog box, and what you want to look at is a percentage of, in our case, serious condition, not serious condition, or zeros and ones, is the percentage for our training data right here. This is our original kind of breakdown. Is the same in our training data set. It doesn't have to be exactly the same, but this is very close. It's about 80-20 in the original data set, the training, and the validation data set. So that's very important that those are very similar. So they are, it worked out well. From this point on, the data sets that are going to be exported, you're going to have two. You're going to have the training and the validation data set. So I'm just going to pull up here and show you. So since we ran this node, this is the exported data sets. We don't have a test because we just didn't create one, but it's just showing the training and validation data sets here, which is exactly what we want. So since we do have missing variables, we have to impute those. We have to put something in the place because we're going to do a regression equation. And since we're going to do that, you cannot have missing variables with a regression equation. So you need the impute mode, which is in modify right here. This node, you do have to change some of the properties here. The missing cutoff. This is just saying if more than 50% of the records are missing, we're going to just throw out the variable completely. So under 50, we're going to impute those values and keep that variable. So the class variable, that's like your categorical variables. The impute method here is going to be a tree, which is kind of hard to explain, but just imagine it like a tree, and these people are all sitting on leaves together. This population has been deemed to be very similar, so they're all on one leaf. So it's going to look at the people to the right and left of this missing value and say, okay, it's kind of similar to these people. Let's impute it with their values. So that's why we're going to keep that as a tree. The interval values we're going to keep as the median because the median is pretty resistant to outliers. It's just a good value to use. So we're going to keep that median. Everything else we are going to keep the same. So we can go ahead and run the impute now. I already ran it, so I'm just going to look at the results. All right, so this is the results here. It's just telling us our impute method, what data it imputed and what the value it was. So a dot here means missing. A dot is fine as long as it's not just completely missing. It imputed the age. It tells you if it's interval or nominal and how many missing there were. So that is good. It's successfully imputed. And we're going to get into the real cool topic of this specific diagram, which is the text mining. Now we're diving into text mining, which is the cool part about our model. These next few nodes will deal specifically with text mining. All these nodes are in the text mining section right here in this tab, right here, all above here. We're going to start with text parsing. This is going to take that sentence or that paragraph that the doctor or nurse put in the symptom text, and it's going to break it apart. It's going to parse it into words so that we can eventually create a numeric value to those words. The properties here kind of help you decide how you want to do that. The parse variable, because we only have one text, it automatically is going to pick that as your variable. You don't have to choose anything here, and after you run it, it will show you right here. Otherwise, it's going to be blank at first until you run it. That's okay. If you do want to change it, you can always go to edit variables, and we only have one here, but if there was multiple, you could accept. You could say yes or no to having it in the model. We're just going to X out of that. We don't need to change anything there since we only have one variable. The language is English. It's going to tell it to ignore just words that don't mean anything, conjunctions, pronouns. It's going like the or a. Those are really not going to give us any value, so it's going to just go ahead and drop those from the list that it comes up with. It's also going to drop punctuation marks. Just seeing it as not valuable. You can change that, of course. Something really cool here is you can have a list of terms that are important to the business and not important to the business, and you can upload them into SAS. This is SAS's default list here that is going to pull up that we have as the stop list. So just like a drop. So if it sees any of this, it's going to just drop those words. This is just the number of terms it's going to show us in the results viewer. So it is ready to run. So you're going to click run. I've already run it. So I'm going to go ahead and click results so that you can see the dialog, or the output, I'm sorry, that it brings up. Now this does take a while, but imagine how long, I mean, this would be insanely difficult to code yourself, or, I mean, by hand, it's not possible. It's too much math. So this is the output that it's going to show you. Shows you how many nouns it kept, verbs, adjectives, all those things, or how many it has. And this is what's interesting, is it shows you a term here. It shows you whether it kept it or it dropped it, and then what type of word it is, and how often it came up, and the rank for the variable itself. And then the parent ID is, we're going to see later that each of these words is going to be almost connected to other words that it relates to, or that it shows up with a lot. And we're going to almost see like a spider web of all these words. And this is just a parent node. This is parent ID. We're going to see this later. So I'm going to go ahead and close that out. After we've parsed our text from a sentence into individual words, we're going to filter them. We've already said what we really wanted to keep and not keep. So the filter node is just going to take those out so that we don't have a million words, some that are just not even significant. The text filter is within the text mining tab here, up here. Now notice as I hover over it, it just tells a little bit about it as well and what it needs to be preceded by. There's not really much to say about the text filter. We're not going to change any properties here. It just needs to be there. The next and final step of the text mining is we need to actually create variables from these words. We're also going to cluster, with this node, it's clustering the words to be in a group, and then that group is going to become a variable, and EM is going to assign a certain weighted number. If the variable is seen a lot, it's going to weight it higher. So let me just run, I've already run this, and there's nothing you need to change over here in the Properties tab. And I've already pressed the results because it does take a second to get the results. So as you can see, it's created 25 topics here, and it's just created a group of words. Like, it just tells you how many terms are in it over here, and this is just some of the terms. Like, and it makes sense. You look, it says seizure, hospital, which is huge. This is what we're trying to predict if they're going to the hospital. Look, seizure, minute, Benadryl, swelling, hive, some of where the sites are that they got the vaccine. Here you have fever, vomiting, and then it does go on. It's got a bunch of more number of terms in there, but it basically just groups the terms in so that it can create a variable that we can use in our model with the text. We did an extra node here. It's not necessary for the models, as you'll see it's not connected here, but it was just for our visual so we can see some of the clusters of text together. Text topic also kind of does this. The text cluster node is up here in the text mining tab still. The properties we changed here, the SVD resolution, we did change to high. It was low initially. And there are 100 dimensions. I'm not even going to go into this because it's so mathematically and just crazy complicated, and this video is kind of getting long enough. But that's set at 100 dimensions. Just imagine, it's crazy. We did want to set the clusters to 10 default on EM is 40, and we want exactly 10. So we changed it to exact from maximum. We want exactly 10 clusters here. But you can change that as well with a specific model. You don't always have to keep it like that. So now we're done with our text mining. We have these variables now that represent our text, but also have a numeric value to them, which is huge. A lot of companies just don't have the depth to do this, maybe the software, but it's a lot of good information that is fed in, and it's good data. It just needs to be structured. It needs to be changed from unstructured to structured so that you can make sense of it numerically in order to put in a model. So we've done that. So now we're going to start doing different models. You'll see these two models down here. We ran the models without text just to compare them and see how different they are. Did text really make a difference? Did it not? So that's why you're going to see some of these come in at the bottom and skip this part, because they're not going to include the text in the text mining. I'm going to make a disclaimer. I'm sorry if you hear my dog. He was whining at the door and I felt so bad, so I decided to let him in, but he's just laying here, so he should be quiet. So now back to Enterprise Miner. We are going to discuss the model nodes now. We did two types of model, a decision tree and a logistic regression. Both model nodes are under the model tab. Decision trees here, regression is over here. So we have to do a logistic regression with this model because our Y, our target, is 0 or 1. It's binary. It's yes or no. You can't have a continuous number like 1.5. You can't have like a kind of yes. It's a yes or a no. They were readmitted or not. So our regression is logistic instead of linear. So you're going to pull the node down, which I've already pulled it. The properties that you're going to change for this specific project. You have the choice to change your polynomial degrees. You really don't want to go crazy with that. You don't want anything more than probably the third power, or the model gets out of hand. We're going to keep it at 2. The regression type, linear or logistic. We're going to do logistic for this model. The model selection. So this is what EM uses, or really anything uses, to decide what variables are going to stay in your regression. You have tons of variables. So what variables need to be selected for this regression? It's going to select the variables that are significant, but how it's going to do it is using a stepwise selection method. Backwards is taking all of the variables in the equation and then one by one getting rid of them if they're insignificant, or they're going to move on to the next. If they're insignificant, it's going to be dropped. Forward is kind of the same thing except for switch. You're going to start off with one variable and they're going to keep adding them on. If they're insignificant, they're going to drop and then they're going to go to the next variable. Stepwise is basically a combination of both backwards and forwards. It's just the best one to use, so we're going to use stepwise in this case. The selection criteria. We're choosing validation misclassification. We want to know the model and the set of variables that is going to give us the least misclassification. We want the least amount or percentage of people that were incorrectly stated as having a serious condition or not. That's why we have that. And then everything else should be the same as the default. So when running the regression, this is the output that you're going to get. This is the complete regression output. It looks a little crazy here. But what you're going to do is search for summary to find the good stuff. Summary of stepwise selection, that is what is going to tell you what variables that the model decided were significant and what together. So it says, based on the misclassification rate for validation data, the model was trained in step 23, which is right here. That means all these variables from 1 to 23 are in the model. All these text topics right here, that is our text groups that we created. That's our text variables, all the different ones that were deemed significant. So they're a group of actual just words. And then we have some of our other variables in there as well. To see the misclassification rate, you're going to look at the fit statistics output. The misclassification rate here is about 15.6% for the training and about 15.9% for the validation. So we correctly, oh my God, I'm having to do math on the spot here. We correctly identified, not guessed, identified about 84% correctly, which is pretty good. That's a good model. So we're going to go ahead and close that here. Actually, there's one more thing we need to look at in the regression, and that is the lift. So the lift is how many times better your model is than just guessing alone, which is a very important business insight. That's what the executives want to know. How much better is this model than just if I just were to look at somebody and guess? Well, this is how it is. This is a training and validation data set. It's a very good thing that they're mirroring each other. That means we did a good job. So for lift, right here you're looking at about 20% of the sample size. And at that specific moment, the model is 2.8 times better than just guessing alone. So we have a lift of 2.8. So that's good. Guessing alone is at 1. So you're 2.8 times better with the model, which executives are going to love to hear. And this is with the text model. Now we'll move on to the decision tree. The decision tree really could go before the impute node because it kind of imputes itself. You don't really have to worry about missing values with the decision tree. It'll take care of it for you. As far as the decision tree, right now we have a maximum branch of 2 because we have a yes and a no. We wanted to split on yes and no. We have a maximum depth of 6 because anything past that, you're going to get very low sample size and it's just not really going to make that much sense. The leaf size, there needs to be at least 30 samples on a leaf. Given our awesome calculus in the central limit theorem, if you have a sample size of 30, it's going to normalize. You're going to, how do we say this? You're going to assume normalization of the data. So you really want your leaf size, and we had to change that from the default of 5, which is insane. You really want your leaf size to be at least 30. You want at least 30 samples to make that statement to say, yes, there's a higher probability with a female sex of having a serious condition. You don't only want like 2 people representing that, and then you're going to state that statement. So you want at least 30 on this leaf, this leaf that contains people of similar variables. Everything else, we're going to keep this for decision here. And everything else is the same as the default. We're keeping this use input ones as a no because if a variable needs to enter back into the tree, if it's very important multiple times, we want to let it kind of do its thing, unless it's too overpowering, which we didn't see that in this case. So I ran the decision tree, and this is the output that you get. This is the tree itself. It looks like a tree. Who would have thought? So what happens is it splits on these variables. And you'll see as you start, we started with 80% non-serious and about 20% serious conditions. After this split, which EM will deem each variable of importance, it'll say this is where the most important split is. Now, this looks a little different because it's our text topic. So these are all our words. These are all specific words. And then you'll come, and this is the weight that it put on the word. It puts certain weights on the word. So if the weight is greater than 0.1035, then your serious condition goes down. If when the data is read in and the weight associated with this variable is in that specific set is less than 0.1035, then it goes up. See, you can see from 19 to 34. And then from there, the tree continues to split. It's a lot of if-else logic. Let's see if we can look at something that is not text. All right, let's look at this, the number of days. Now, you do have to follow down the tree. So in this case, if all these other conditions to get to this point were met, the number of days, and we had imputed this because it was missing, so that's why it says that. If the number of days since the onset of the serious condition after they have the vaccine is greater than 0.5, the chance of them having a serious condition goes from 47% to 59%, so it goes up. If it came on maybe quicker, 0.5 days, or if it was a missing value, it goes down. So the serious condition will go down, the probability. Similar to regression, we look at the lift chart to see how much better, oh my gosh, my English right now, how much better the model is than guessing. At 20%, it's about 2.5 times better than just guessing alone for the decision tree model. We'll also look at the misclassification rate here in our fit statistics output. The misclassification rate for the validation data set is about 15.98, so it's kind of similar to the regression, which is still not bad at all. So now we are coming to almost the end of Enterprise Miner. We are going to compare the 4 models, the decision tree and regression with the text mining and the regression decision tree without the text mining. These have the same properties of these, so I didn't really show these on the video, just we didn't connect it to the text. That's really the only difference there. The model comparison node will compare all the models that kind of are fed into it. So you see all 4 of these models are converging into this one node. I have the results pulled up right here. EM will just pick the model they think is the best. This one is the regression with the text mining included, the text mining variables included. It'll compare the misclassification rates. Now you see here the models, both of them with text, they had a misclassification rate about 4% lower than the ones that did not contain the text. So we're already seeing that the text has value, the misclassification rate is going down with adding those variables in. Now let's look at the lift. Let's see how they all did. This is a lift. This is the training and the validation data set and all 4 of the models. Right here is kind of them connotated with the colors that they have. So this one right here is the regression with text. Look how much better this is than the regression with no text, which is here. That's a big gap. That's a pretty big gap. This one is almost 3 times better than guessing alone, and this is not even 2. So that's huge. That's a huge business value to add the text in. As you can see from this chart, the decision trees are also in there. Again, the decision tree with text has a higher lift and a lower misclassification rate than without text. So this is huge right there. This is a great example of needing to add text mining and add that as part of the data to make decisions in the business. So now we've come to the end of the model, and this last node right here is the score node. This is the most important node in the entire model because this node is the one that actually gives the business value. We've created the model in all the steps above, and it's sitting in the model comparison, the winning model is, which is the regression with the text. But if it's just sitting there, we're not really using it, what good is it? So we're going to score it. We're going to use the score node on new data, and that's going to tell us the probability of a patient going to the ER or not. So as far as the new data, this is the new data here. It's a 2016 Vaers data set. All I did was create a new data source, kind of what I did before, take it and drag it. Now, there are some properties here I want to go over. First, the property you need to change, the role is going to be, I believe it's raw as a default. You need to change it to score because we're going to use this data set to score. Another thing is, when you edit the variables, it's not going to be exactly the same as the 2015 that we read in because we don't have a target right here, which is fine. We created the target, as Stanley has showed you in SAS Studio, out of the data set, but the data set naturally doesn't have the target because the ER visit really is the target. But you'll notice serious condition is not in here because we kind of manually created that to make our model from the 2015. If you do have a target in here, then you just need to reject it before it's scored. The score node knows what the target is, and having that extra target in there is just going to confuse it. As far as the score node goes, this type of score data, you want to change that from view to data. Changing that allows the exported file to be a SAS data set. And then you can read it into SAS Studio, kind of play around with it, and you can read it into Tableau is what we did. If you have it in the view, it's not going to export a data set that you can do anything with other than just look at. So we switched ours to data. Now that the properties are all correct, we're going to go ahead and run the score node. I already did this, so for time's sake, I'm not going to run it while you guys are watching me. That'd be super boring. So this is the results screen that's going to pop up after you run the score node here. This is a really cool part. This is all the SAS code that EM wrote in the background with dragging and dropping those nodes. This is all the code. We did not have to write any of this, and it contains some macros in there as well. So this saved us a lot of time and just general anxiety. Anybody that's written code before can understand. So what you can do is you can actually copy and paste this into SAS Studio to run it and import your data, write some code to import your data set in SAS Studio there. And with the help of SAS support, shout out to Craig who helped us did that. We successfully did do that in SAS Studio. But the real important part of the score node is going to be right here in this exported data. There's 3 little dots here. We're going to look at the score data set that the score node created and exported here with the new data set. So it's right here, the score. So this is the SAS data set that you'll be able to see in SAS Studio as well. And we went ahead and downloaded that from SAS Studio, and that is how we were able to get this score data set, the probabilities data set, into Tableau to make visualizations that you'll see on the website. So click Explore. I already did that as well. This is where you're going to get when you click on Explore. The main thing you're going to want to look at is this down here. This is all your variables. This is a new data set basically, but the best column, the column that we really care about, is right here. Predicted serious condition equals 1. That means what is the probability of that patient coming to the ER? This patient, and I just sorted this so you can kind of see, this patient has a 99% probability of coming to the ER. And it just kind of goes down as the column goes down, and it has scored each patient. So this is really the cool part. This is what the execs want to see, and this is what we wanted our model to deliver here. That wraps up our Enterprise Miner part of the project. If you're still watching this video, I'm sorry, and congratulations because it's over. Thank you.